everyone. So in this video we are going to discuss about the chapter gravitation. So gravitation is nothing but the attraction of all objects towards the earth. So whenever you throw any object upwards, it comes downwards due to gravity. So any kind of object can be thrown upward, it will reach to a certain height and reaches down due to gravitational force. Okay, so in all the objects we have gravity, we all stand due to gravity, and all the planets are also having gravitational force as it revolves around the sun. The moon goes around the earth because of gravity. So gravitation is not only there in earth, it is also there in space. Okay, so moon goes around the earth. An object when thrown upwards reaches to a certain height and comes downwards. It is said that when a Newton was sitting under a tree, an apple fell on him. So Newton started thinking that why the apple fell down in the downward direction and stuffs. So what made the apple come down, and which is attracted by the earth. So earth is having some gravitational force, so the apple comes down. So he came to a conclusion that if earth can attract an object, why cannot an earth can attract a moon? Because moon goes around the earth. So is the force same in both the cases? He was thinking a lot. So that he gave an activity that take a piece of thread, okay, tie a small stone at one end, hold the other end of the thread and whirl it round. Note the motion of the stone now. Release the thread, again note the direction of the motion of the stone. When the thread is released, the stone moves in a circular path with a constant speed. It changes its direction every time. Okay, the change in direction involves change in velocity or acceleration. The force that causes this acceleration and keeps the body moving along the circular path is acting towards the center. So this force is called as centripetal force, as it is called as the force is acting towards the center. Okay, so the stone flies off along a straight line. This straight line will be tangent to the circular path. So the motion of the moon around the earth is due to centripetal force. The centripetal force is provided by the force of attraction of the earth. If there were no such force, the moon would pursue a uniform straight line motion. It is seen that a falling apple is attracted towards the earth. Does the apple attract the earth? If so, we do not see the earth moving towards the apple. Why? According to the Newton's third law of motion, the apple does not attract the earth. But according to the Newton's second law of motion, for a given force, acceleration is inversely proportional to the mass of the object. So mass of the object is negligibly small compared to that of the earth. So we do not see the earth moving towards the apple. Extend the same argument for why the earth does not move towards the moon. In our solar system, all the planets go around the sun. By arguing the same way, we can say that there exists a force between the sun and the planets. From the above facts, Newton concluded that not only does the earth attract an apple and a moon, but also the objects in the universe attract each other. This force is called as gravitation. And he also discovered a universal law of gravitation, concluding that there will be two objects which is separated by a distance d. Every object in the universe attracts every other object with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of two objects. Okay, so F is equal to G m by d square. Let two objects A and B of masses m and m lie at a distance d from each other. Let the force of attraction between the two objects be F. According to the universal law of gravitation, the force between two objects is directly proportional to the product of the masses. F is directly proportional to capital M small m, and the force between two objects is inversely proportional to the square of the distance between them. That is, F is directly inversely proportional to 1 by d square. We have to combine both the equation, and he came to a conclusion F is equal to G m by d square. So G stands for the gravitational constant. Okay, it is a constant of proportionality. So it is a universal gravitational constant as well, as I said, and the value of G will be 6.67 into 10 to the power minus 11 m square kg minus 2. So universal law of gravitation states that every object in the universe attracts every other object with a certain amount of force, okay, which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. And the formula will be F is equal to G mm by d square. Okay, so this is all about the topic.